you probably already know that the derivative in this case of gx times f of x is given by gx times the derivative of f plus the derivative of g of x times f of x. It means there is a cross term. It's not just a product of the derivatives. I hope you already know this. If you don't, or if you forgot, again, these are all good times to remember and revise differentiation rules. Most important though, at the moment, is to prove that this is the case. Perhaps you were told, you just believed it, and you went along with it. Now we're going to show that this is really the case by using differentiation from first principles. First of all, let's use a little bit of physics 111 magic and get rid of this part. We have space now to do the derivation, and you can also find it in section 5.2.5, product rule. The other ingredient that we'll need in order to use differentiation from first principles is to calculate what j of x plus h is, which, given the definition, is j of x plus h times f of x plus h. This allows us now to write the derivative from first principles of j of x, and I'm going to sub in directly into the formula. This is the limit when h goes to 0, j of x plus h, f of x plus h, minus j of x times f of x over h. When we get to this point, as in other demonstrations, there are small tricks that you can do. In this case, just like for the quotient rule, the easiest way is to add and subtract a term that will contain g of x or f of x. And you will be able to manipulate them in order to then use the properties of limits and prove the product rule. Let's try it. In this case, the term that we're going to be adding and subtracting is f of x g of x plus h. So we'll be adding and subtracting to the numerator. Let's try it. Once we get to this stage, what we really need is to identify terms and group them together. For example, we can see that f of x plus h is being multiplied by x plus h, and we also have minus f of x gx plus h. So we can start by writing that this is the limit when h goes to 0. And let's try to group terms of f x plus h minus f of x, and you will see where this is going, multiplied by g of x plus h. And we can do something very similar to terms being affected by f of x on both sides. This means we can write f of x multiplied by g of x plus h minus g of x divided by h. And we can see why this is so crucial, and we're almost there. So you'll see that the limit of the sum is the sum of the limits, and also the limit of the product is the product of the limits. To do this, we'll need to clear the board up here. So we'll magically make things appear on this side for clarity. And what we're going to do is to use the properties of limits that we've covered in section 3 in order to identify the different terms in this limit. We'll start by writing limit when h goes to 0 of f of x plus h minus f of x. times the limit when h goes to 0 of g x plus h. We've just split this. This is all fine because we're using the properties of limits. We're now going to split it up with the sum property plus the limit when h goes to 0 of f of x times the limit when h goes to 0 of g of x plus h minus g of x over h. We're keeping the h's here. It's all mathematically correct. Same thing here. And the good news is that we can identify these terms. This, from first principles, is first derivative of f of x. This limit is easy to calculate. When h goes to 0, g of x plus h goes to g of x. Plus, this case, when h goes to 0, f of x just goes to f of x. And this limit from first principles is the derivative of function g of x. So it means that we have demonstrated the product rule. Therefore, because we've demonstrated, we can now use it, but now you should really understand how we can get it from first principles. It doesn't just fall from the sky. You can demonstrate it mathematically. And the next one, which is a little bit more tricky, quotient rule.